So this question is again in the vertical dimension, but now instead of the ball just falling down, you have two directions. First it goes up, and then after that it goes down, right, towards the bottom of the cliff. Now they have actually simplified the question and tell you that air resistance is very small. So when they phrase it like that, you can basically say that your air resistance is always equals to 0. But this only applies when the ball is moving upwards. So when the ball is falling down, you cannot ignore air resistance. Okay, only when it goes up. So now they are asking you to talk about the direction and magnitude of just acceleration of the ball. Okay, after it leaves the student's hand. That means the ball is going up or down? Going up, most likely. Okay, so you are talking about it moving up, and then after that at the highest point. So since air resistance is 0, then your free body diagram, once the ball leaves the hand, the only forces that is acting on the object is just the weight. Other than that, there's no other force because there's no air resistance. So as the ball is going up, there's only weight. So now if I go and write down I want to analyze acceleration, right? I need to make use of two equations. Number one is your F net equals to ma. The second equation that you need to use is your F net is equals to sum of forces. So actually, this is at the beginning. Of course, we will write down both equations, but most of the time, we know that eventually we are going to combine these two. So most of the time, we will just write down sum of forces is equals to ma, because down here, this is what F net means, and then down here, this is your Newton's second law. So since in this particular case, the only force acting on the object is the weight, you can then write down W is equals to equals to ma. Yeah, and then for physics, right, most of the time we will expand the thing left hand side to left hand side, right hand side to right hand side. So W, how to expand it? After I expand W, it will be mg. Ma, I got nothing to expand, I will get this. Since mass are the same on both sides, I will get A equals to G. Now what does this tells me is that it means from the point it leaves the person's hand until the object reaches the maximum height, because the question says there's no air resistance, I can actually conclude that the acceleration that is acting on the object is just A equals to G. So once I know that, then magnitude of acceleration, well, both of them will be 10 meters per second square, because that is our Earth gravitational acceleration. And the direction of acceleration will always be downwards. You should spell it out, okay? For me, I will just put arrows. Now after that, they gave you the displacement time graph. So in displacement time graph, there's a difference between speed time graph and displacement time graph. In a displacement time graph, the gradient of your displacement time graph actually gives you the velocity. Yeah, so down here, as you can see, if I look at this point, you can see that the gradient is positive. Then after that, if you look at this, you can see that the gradient is negative. So it means that down here, your velocity is positive. Down here, your velocity is negative. And what do we say about the sign of velocity? Can you recall? We say that, I think it's here. Is it here? Yep. We say that the sign of your velocity actually does tell you the direction of motion. So actually down here, you can see that at first the ball is actually going up, right, into the air. It is going up into the air. So when it is going up into the air, velocity is positive. When it reaches the maximum height, yeah, then the velocity becomes negative. It starts coming down. So that's why I say the sign of velocity tells the direction. Yeah. So one more thing you may want to take note right down here is that you can notice that the sign of your velocity, in this case, it is basically the gradient, will basically indicate to you the direction of motion. Yeah. Okay, then some of you may be asking, teacher, how do you know this one is maximum height? Hey, come on you see it start with from the cliff top, right? So this is the cliff top. This is the cliff top. So the ball from the cliff top actually start here, 1 meter. So I think the person quite short, only 1 meter high, because the person holding the ball yeah. So basically from here to here is 1 meter, right? So I will not draw the human. This is the ball, okay? So at time equals to 0, my displacement is 1. Then when it reaches, then it will go up, right? Go up until maybe this is a 1.678. When it is going up from here, I couldn't draw properly. So from here all the way 1.678, 1.8 meter. Then you can see that now the displacement coming down. So meaning that the ball will start to come down, all the way when it reaches 0. 0 is not the bottom of the cliff. 0 is just the cliff top. Meaning that down here, when it reaches 0, right, it actually the ball only comes back to here, top of the cliff. Okay, so this part of the journey, it is not shown in your displacement time graph. Okay, so that's how we interpret the thing. Let's look at what are the questions. So so now they are saying that air resistance is very small. So down here they are just trying to say that your air resistance can be equals to 0 between your T equals to 0 to 1. Yeah, and we already proved that when your air resistance is 0 down here, this is when your air resistance is 0, right? That's why you don't see the air resistance component. Your air R is actually equals to 0. Yeah, so you only have the weight. So when you only have the weight, you can see that your acceleration is g. That means your acceleration is constant 10, okay, downwards. So down here what happens is that you should know that between t equals to 0 to 1, then your acceleration is equals to 10 meter per second square downwards. Yeah, you are asked to actually sketch the velocity time graph for the first 1 second. So you see, once we understand all these concepts, now we just need to apply, right? So we know that your velocity is rising, right? From is it rising? No. Is it rising? Think about it. So you have a person throwing the ball up, right? So when you have a person throwing the ball up, it will throw with very high speed. Then after that, when it reaches the maximum height, then your velocity will be 0, right? Then after that, your object, okay, maybe I shade the object. Your object then will, from v equals to 0, it will speed up. And then when it come back to here, it will speed up even more. This is the velocity. Okay, this is the velocity. So let's see, how do we draw this? So when does it reach the maximum height? When do we reach the maximum height? We need to find out when does it reach the maximum height. So it reached the maximum height, we can actually find here, right? It actually reached the maximum height at 0.4. So now we know that at 0.4, this one, at t equals to 0.4, your velocity will be 0. So let's mark that out. So at 0.4, my t will be 0. At the very beginning, initial velocity is shown as a. So they didn't tell us the value, but they tell you that, at the very beginning, my velocity is a, right? So what happens is that when I throw the ball up, I will experience a acceleration in the downward direction. So what happens is that if your velocity a is upward and you have a which is 10 meter per second square downwards, it means that every 1 second your speed is going to drop by 10. Yeah, so I know that at 0.4 I will reach v equals to 0, and it is constant acceleration. So when my acceleration is constant, in another word, basically the gradient of a vt graph will also be constant. and this constant is of course 10 lah. So I know that gradient constant means it's a straight line, so I'll just draw a straight line, right? After that, it says that in the first 1 second your acceleration will always be constant, so I just need to draw from this point to this point. If the gradient is constant, it means that my line will just carry on straight. Finish. Yeah, how do I know that it will enter into the negative region? Well, because after your ball is at maximum height when v equals to 0, after that it is going to change direction, right? Downward, and the downward speed is getting bigger and bigger. So that's why from 0 speed, this is 0 speed, to maybe, I don't know, some speed here, then after that eventually to another speed here. Yeah, this reading here will give me the speed, right, at different time. Yeah, so that's how I sketch my VT graph. And you can see that your VT graph is a straight line. Why? Because the acceleration throughout in the first 1 second is constant, because there's no air resistance. Air resistance is very small. I ignore it. Can? So now I have to answer the following question. Now it refers me back to the displacement time graph. So I have to look at my displacement time graph over here. Okay, and the question says, how does the graph show that terminal velocity is not reached? Now, in a displacement time graph, if I reach terminal velocity, what does terminal velocity means? It means that your velocity has become constant. Am I right? And I know that in a displacement time graph, velocity is given by its gradient. So if the object has reached terminal velocity, I would expect that the gradient of my displacement time graph would become constant as well. So now when I look at my figure 4.2, in the first 1 second, so this is figure 4.2 in the first 1 second, that means from here to here, can I find anywhere in this graph whereby my gradient is 0? Or when my, I shouldn't say gradient is 0, the gradient is constant. Is there a part in this graph whereby I have a gradient that is constant? Gradient that is constant? No, right? So that's why you can see that in Cambridge, they only gave you 1 line for 1 mark, because they expect you to answer to the point. Okay, so down here you don't need to explain much. They just require you a short answer. That's why they say state how. Okay, so very straightforward. So you just need to say, in the first 1 second, the gradient of your displacement time graph, please spell it out completely, is never constant, or is not constant. Okay, very straightforward. Now let's look at the last part. When the ball continues to fall, the effect of air resistance becomes significant. So it means that there's air out, okay? And the ball basically reached terminal velocity. So once you see this phrase in your mind, you should immediately relate to here. This expression. This expression is basically what terminal velocity is all about. So down here, for those of you who are seeing my video in parts, then you need to know that as the ball falls, there will be 2 forces. Because it is speeding through air, there will be weight and there will be air resistance. Now this air resistance, basically it is a changing number. It will actually rises when the speed goes up. Okay, so once you have that, you will notice that your F net is given by W minus R, and using your Newton's second law, F net is equals to MA. So you can see that for this particular term, W minus R, it will become smaller and smaller because your R actually become bigger and bigger as it speeds up. Yeah. So what happens is that when your R becomes matching with W, you will notice that the right hand side becomes 0. This is when A is 0, and this is whereby your V will become constant when your R equals to W. This is why. So now you need to describe the velocity and the acceleration at terminal velocity. I think it is way easier. How would you describe velocity? Velocity is the noun. So to describe it, you need two adjectives. Like what I say at the very first question, you will need two adjectives. So at terminal velocity, what happens is that your velocity become constant, it no longer change. So velocity is constant. In the case of constant, then one adjective is enough. Yeah, then after that, acceleration. So if your velocity is no longer changing and acceleration is a measure of how quickly your velocity change. So since now your velocity is not changing, basically your acceleration is 0. It's no longer there. You can see from here. Right?